Hello, welcome to Edge Computing in today's cloud world. My name is David Williams, and I'm a managing principal in a HEADS advisory practice. In this webinar, we will discuss what exactly comprises the edge and why should we care. We'll review the 5 drivers for edge computing, as well as edge use cases and the key challenges that organizations face as they adopt edge computing. We'll take a look at cloud and edge working together, providing a more holistic solution for the enterprise. We'll also provide some guidance based on our customer experience. So what is the edge and why should we care? To better understand why the edge is so transformational and how it will impact your organization, it's important to grasp a hold of 3 key facts. First, edge is a strategic complement to those enterprises that have already adopted cloud computing. In the same manner that cloud computing and services have become pervasive in the enterprise, so too will edge computing. In fact, as we'll discuss later, the cloud and the edge have a symbiotic relationship. Second, edge is a disruptor, and while other recent technology disruptions have focused on application and data trends, the edge differentiates itself as an infrastructure play. Third, and most importantly, the edge is inevitable and ubiquitous, thanks to new digital business designs, moments, and interactions. Let's look at an example of how all of this fits together using a customer story of ours. In this example, a certain Café-Style restaurant chain wanted to change the way they developed, packaged, and delivered, and ran and operated applications that managed their thousands of restaurants. As part of this transformation, a group of applications were selected to run closer to the customers for an improved experience for both patrons and cafe employees alike. However, they encountered several problems and challenges along the way. Outages were experienced whenever access or connectivity to the core was interrupted. Even during planned maintenance windows, several regional or nationwide cafe outages were encountered. Because of the nature of their applications and the fact that data needed to be aggregated to be processed within their data centers, their processes were more batch-oriented, really not conducive to real-time engagement with the customers that visited the cafes every day. Finally, it became more and more difficult to release new features and capabilities to a subset of the restaurant locations, and they became more error-prone with every release. So how did they design their edge, and what technologies did they invest in? In this example, the customer chose a specific technology stack for a device edge deployment. In order to minimize the hardware footprint in each location, they implemented network routers with embedded x86 compute capabilities. They adapted their network connectivity to the corporate office, the cloud, which served as their core, and the internet, leveraging the intelligent routing capabilities of a software-defined WAN or SD-WAN solution. They also turned to containerization versus traditional server virtualization as the preferred way to package, distribute, and run their applications. What about those applications themselves? Analytics and reporting applications remained at the core since they were used more by corporate users than by users at the locations, while order, food, loyalty, and payment applications, those deemed as cafe operations, were moved to the edge. In addition, application performance monitoring tools were employed throughout both the core and the edge computing tiers for greater observability across the distributed landscape. As a result of their investments and focus on edge computing, they achieved greater control over the business operations at each location thanks to real-time actionable data and localized events. Each location could manage their own campaigns, focusing on what was important to their local market. New features and capabilities became more frequent and easier to release to targeted locations. Retail operations continued with greater autonomy, reducing the impact caused by access or connectivity outages to the core. And with increased business insight and innovative applications made possible by edge computing, they were able to better manage costs, maximize profitability, and enhance customer experience and loyalty. Looking even closer, we can see how edge computing affected even their approach to DevOps and release automation. As a complement to the existing cloud operations, where development, test, and other pre-production environments existed, Edge became the new destination for integration releases and ultimately production rollouts across their Café portfolio of thousands of locations. Regarding the ubiquity of the Edge, let's break down the topology into its various components. Edge architecture is comprised of three distinct environments: the Edge, or the architecture's namesake, edge computing, and the core. The edge is the physical location where people and things, or endpoints, interact with the digital world that surrounds them. This interaction is often characterized by data and information about the physical world gathered by sensors or other devices, and some form of control that the endpoints have over their physical environment. Edge computing is a distributed computing model where edge data and events are received from those endpoints and processed while control commands are sent to the endpoints to effect some type of change in their physical environment. Edge computing is often in close proximity to the edge, but not at the edge itself. The third and final environment, referred to as the core, can be a centralized data center, service provider, or even a cloud provider. The core is often where management and control of the other two environments takes place. It's quite common that a single core may actually manage tens, hundreds, or even thousands of edge and edge computing environments at scale. One key point to remember, though: an edge without a core is the edge of nothing. By this, I mean to say that all three environments must exist to have a complete and well-defined topology. An edge without a core is just a localized, standalone environment. Within this topology, there are multiple destinations or locations where the edge itself may be placed. The device edge is what most people think of when they envision the edge. This is where devices are quite literally located in the physical environment in question. The most common devices are embedded, wearable, or sensor-oriented devices that utilize a wide range of infrastructure, transport, discovery, data, and semantic protocols. The gateway edge bridges the local environment with a more distant one, usually within a limited number of hops to minimize latency and expense. The compute, local data center, and regional data center edge destinations are even further away from the devices, but provide varying degrees of compute and storage capacity. As you get closer to the core, these edge destinations begin to look more like common data centers, though not to be mistaken as the core itself. These 5 destinations are also referred to as the enterprise edge, shallow edge, or deep edge, depending on the remoteness from the core. So what makes companies like that restaurant chain and others adopt the edge? Let's look at the 5 drivers for edge computing. As we look across our customers that have adopted edge computing, we find 5 common motivations. The first driver is data and bandwidth, where massive amounts of data is generated and collected. Often, the dataset only has local value, or possibly just a subset of the data in aggregate has value. The second driver is local interactivity. In this case, there's a high rate of collaboration or chattiness, especially among highly collaborative systems. Third, limited autonomy. It's important to continue business operations during network outages or during periods of limited connectivity. Fourth, privacy and security. In this case, our customers needed to adhere to regulatory or industry security requirements that governed how and where data is stored and processed. The fifth driver is latency. Here, it was important to reduce latency by processing data as close to its point of origin, mitigating the limitations of and traversing to the core. In other words, making the interaction more real-time. Now, these 5 imperatives are not only useful in determining whether edge computing is right for your organization, they also aid in selecting an edge destination. Customers that have been successful adopting edge computing began by evaluating the 5 drivers against organizational requirements and constraints determining their importance and priority. Once those requirements are adjusted, one, maybe two edge destinations will stand out as the best fit for your use case. And this leads us to a discussion about edge use cases. What opportunities are there within your organization to take advantage of edge computing? But first, a quick opportunity primer. The edge is not synonymous with the Internet of Things. While IoT is the most commonly discussed use case associated with edge infrastructure, there are plenty of other use cases. Let's look at 8 use case categories that are common in edge computing deployments. Highly immersive use cases engage people for collaboration, interaction, and reporting. This category is focused on the user experience in real time. For this reason, we see deep and in some cases shallow edge destinations as best optimized for use cases like this. Personal monitors, that's another category of use cases well suited for deep edge, in the physical environment with or on the devices themselves. In comparison, content delivery use cases have quite different characteristics. Content delivery systems often store large volumes of static content and have a latency tolerance level that doesn't require placement at the device edge. Some content delivery use cases, such as media providers, are usually managed at a regional level, placing application workloads and data in regional data centers, or RDCs. As the content becomes more diversified and specific to a given location, local data centers at the shallow edge become viable destinations as well. We see shallow edge also meeting the requirements of system device control, automation, and maintenance use cases, as well as distributed business processing and data and event reporting, although the enterprise and deep edge destinations may be viable candidates as well. Finally, event correlation use cases such as fraud detection systems usually require larger amounts of compute capacity, along with complex interactions with more centralized systems, making the enterprise edge the ideal destination for such scenarios. Keep in mind that these generalizations may not apply to your specific use case, and we encourage you to make a more detailed analysis of the 5 drivers and the specific technologies available to you when choosing an edge destination for your initiatives. Let's now take a look at some of the key challenges and considerations of edge computing. These challenges fall into 4 classifications: locations, diversity, protection, and data. For the first key challenge, locations, organizations will have to determine how they'll address a few factors, specifically scale, environmental, and remote management and autonomy. Scale can widely vary in number and size at the edge, from tens to thousands, and from very small to extra large. At the edge, the operating environment is quite different from a traditional enterprise data center, usually lacking raised floors, redundant cooling units, and generators for backup power. And often without local on-site IT support, how IT will manage all of those endpoints remotely is critical. It boils down to the ownership model, whether the enterprise will own and manage edge infrastructure from the enterprise core or leverage an as-the-service solution. In summary, some of the considerations to take into account are management, connectivity, security, compute, and storage. Diversity is the next key challenge, with the myriad of use cases and their unique requirements. And while popular, nonprofit organizations, communities, and foundations are working hard to standardize various aspects of edge computing, selecting the right technologies for your edge deployment and topology may result in a highly customized solution architecture that's quite different from others. For these reasons, successful edge implementations typically leverage consulting partners with particular expertise in edge technologies and adoption. The final 2 key challenges are interrelated and address data protection, security, and governance. Regarding protection, data security, privacy, and compliance standards should be extended from the core to the edge. Because of their interaction, organizations should apply the same rigor and due diligence at the edge to minimize the attack surface of edge infrastructure despite the small footprint that it entails. Attention should be paid to geographical and local regulatory requirements for data privacy and sovereignty. We find that taking a zero-trust approach to data protection, along with intelligent operations, tends to check all the boxes for even the most strict organization. As we discussed earlier, the value of data created, collected, and processed at the edge may mostly have local value. While the volume of data can be substantial, datasets tend to be quite small and have a high noise ratio, especially from a corporate view. As a result, data integration and analytic solutions and processes may need to be revisited, along with the infrastructure considerations, such as small yet performant compute and storage devices, connectivity, and security infrastructure. All of those challenges and considerations may seem like a lot at first, but many of them can be addressed by combining the edge with public cloud as the core. Many organizations have already been quite successful moving to a cloud operating model, and cloud computing is a natural, if not optimal, counterpart to edge computing. Organizations are turning to the public cloud as an alternative to the traditional enterprise data center. Among the benefits of the cloud plus edge approach is long-term analysis. The reason for this becomes apparent when you look at the large troves of data that must be stored persistently for meaningful data analysis. Public cloud storage has practically infinite scale and consistent performance. Similarly, on-demand compute capacity is extremely scalable in the cloud with various hardware architectures, including GPU-based and ARM compute platforms becoming more available, making large-scale processing possible. Add the global footprint these hyperscalers have with tremendous amounts of fast and highly available network bandwidth, and it's easy to see why the cloud is the ideal location to place command and control services that would be infeasible elsewhere. And public cloud providers are increasing their offerings and the variety of services for the edge, practically extending their services to edge devices with familiar cloud management, analytics, and durable storage. These services address use cases such as fleet management and machine learning, while promising accelerated development, faster and more efficient analytics, and improved security of device data, connectivity, and communications. And all three hyperscalers, AWS, Azure, and Google Cloud, have offerings that provide virtual and even physical infrastructure solutions for every destination along their edge continuum. If all of this seems a bit daunting, we have some guidance based on our experience delivering edge solutions to hundreds of customers of all sizes. We recommend that customers begin by identifying their specific requirements and objectives for the edge solution, such as zero-touch deployment, automatic connectivity, and high reliability and security. We also recommend answering some additional questions to scope and define characteristics of your edge solution, including but not limited to how you will provision, manage, and maintain edge devices and edge computing infrastructure, and what your target lifespan will be before replacing them. Finally, we recommend a consultative approach to the edge, beginning with the creation of a holistic infrastructure strategy for the edge based on customer initiatives and current and future plans for the cloud and data center. Identify fit-for-purpose solutions that match your existing investments with complementary edge technologies that will provide rapid insight into your data and interactions with high-performance local services. In summary, developing your edge solutions will require 3 steps. First, developing edge architectures that devote resources toward customized and consultative approaches for edge infrastructure. Second, developing and standardizing tailor-made deployment blueprints comprised of fit-for-purpose technologies that meet your specific use case and situation. Third, employ skilled architects and engineering resources to design and deploy your edge solutions. There are some common trends that we see across different approaches to edge computing. Leverage familiar hardware wherever possible, such as x86 compute platforms, followed by low-power ARM devices, with appropriate connectivity and storage fit for the use case. Many off-the-shelf components can be used versus customized and proprietary hardware. Also, open-source operating systems and software further reduce the cost of implementation and operations as well as reducing risk. What about where to start? We see an evolutionary approach to edge adoption, beginning with the single project with an opportunistic use case. These small successes often lead to full adoption for a given business unit or even multiple business units as referenceable patterns, architectures, and approaches become standardized in the organization. In some cases, the all-in approach may be the ultimate goal. In these cases, forming a community of excellence or a working group focused on the edge and its role within the organization may be a worthwhile long-term investment. To wrap up, we extend a call to action. Start collaborating with enterprise stakeholders today to identify use cases that can be addressed with edge computing. Remember, infrastructure-led disruption. Over the next 3 months, begin building a strategic plan for edge computing as an integral part of a broader digital business strategy. And over the next 12 months, do 2 things. First, pilot an edge computing project to experiment, build expertise and partnerships, and quantify benefits. Second, identify skills and operational changes needed for future projects by creating a community of excellence or a working group around a specific edge project. Those organizations that follow this pattern of adoption will safely navigate the pitfalls that lie ahead and will accelerate the realization of business outcomes that will come from their investments at the edge. We hope that you've enjoyed this discussion on edge computing in today's cloud world. For more information about this and other topics pertaining to enterprise cloud infrastructure, intelligent operations, and modern applications, please visit thinkahead.com.